Today we are going to learn about complex fractions and unit rates, and we are on chapter 1, lesson 2 in your book. So we'll go back to the essential question, how can you show that two objects are proportional? As we go through this chapter, we will understand the meaning of proportional, but for this lesson, we need to know what a complex fraction is first, okay? So let's go to the real world example, the real world link, and let's see how complex fractions work in the real world. So Dana is skating laps to train for a speed skating competition. She can skate one lap in 40 seconds. So in 40 seconds, Dana can finish one lap. Okay, so we want to write a ratio in simplest form from comparing Dana's time, Dana's time to her number of laps. So when you say Dana's time to her number of laps, Dana's time becomes your numerator and the number of laps becomes your denominator. So in this case, Dana's time is 40 seconds. So we write down 40 here. Number of laps will be one lap. Okay. Now let's take this a step further. So Dana can skate one lap in 40 seconds. Suppose Dana, I'm now number two, Dana skates for 20 seconds. How many laps will she skate? Okay, so if you notice 20 seconds, okay, if we make this into a fraction, is only 1/2 of 40. Okay, so how many laps will she skate? If Dana skates only 20 seconds, then she will complete 1/2 of a lap. Okay, make sense? So if you cut the time in half, you also cut the number of laps in half. Okay, so if you want to write this again as a ratio, write the ratio of Dana's time from exercise 2 to the number of laps. Okay, so Dana's time now is 20 seconds. Okay, and the number of laps that she will complete in 20 seconds will be 1/2. So this is a good example of a complex fraction, and we will learn to simplify that in this lesson. Okay, let's take a look at the concept right here. Let's define what a complex fraction is. Fractions like 20 over 1/2 are called complex fractions. Okay, complex fractions are, let's define complex fractions. Okay, complex fractions, fractions with a numerator, denominator, or both, okay, are considered to be complex fractions. So when you talk about fractions with a numerator or denominator or both that are also fractions, so when you have a numerator or a denominator or both of them that are fractions, okay, they are called complex fractions. Complex fractions are simplified when both the numerator and denominator are integers. Meaning to say, okay, what it's saying here, complex fractions are simplified when both the numerator and denominator are both integers. So there should only be one fraction bar, okay, in simple terms. If you have multiple fraction bars, it is not yet in simplest form, okay? So what that is saying is that if your numerator and denominator is an integer and not a fraction, okay, and you only have one fraction bar, then you have a complex fraction as considered to be simplified. Okay, so let's take a look at example one. Let's see. Okay, so you have 1/2, 1/4 over 1 or over 2. Now you notice this problem right here. You have to identify your main fraction bar. The longest line is your main fraction bar. Okay, and you notice you have two fraction bars here. One is shorter, this one, and one is longer. The longer one is your main fraction bar. Okay, and let's see how this works. So if we look at this one right here, So recall that a fraction can also be written as a division problem. So remember the main fraction bar indicates division right there. Okay, and we take this now. When you say 1/4 over 1/2, it is the same thing as saying 1/4 divided by 2. So we convert our main fraction bar into the division sign. So you now have 1/2 divided by 2. We learned from chapter 4, okay, that when we are dividing, we are actually multiplying by its reciprocal. And that's exactly what happens here. We multiply the reciprocal of 2, okay, in this case, which is 1/2. So the reciprocal of 2 is 1/2. Remember what the reciprocal is, right? Okay, two numbers whose product is 1. So when I multiply 2 times 1/2, they equal 1. So therefore 1/2 is the reciprocal of 2. So I multiply 1/4 by 1/2, okay, and we simplify, we end up with 1 over 8, okay? So how did that happen again? Just to recall, 1 times 1 is 1, 4 times 2 is 8, okay? So 1/4 over 1/2, okay? 1/4 over 2 is equal to 1/8. So that is example number 1. Let's take a look at example number 2. Simplify. Again, you have two fraction bars, and according to the definition of simplest form, you only need one fraction bar for a complex fraction to be in simplest form. So again, if you notice, the longer fraction bar is here. Okay, that is going to be your division sign. So if we have 1 over 1/2, okay, and write the fraction as a division problem, this is what's going to come out. So now we have 1 over 1/2 is the same as 1. Look at our main fraction bar, becomes a division sign, 1 divided by 1/2. And remember, when we are dividing fractions, we are multiplying it by its reciprocal. So we simply multiply the reciprocal of 1/2, which is 2 over 1, okay? And we simplify it to get the reciprocal. 1 over 1 times 2 over 1 will be 2 over 1, or simply 2. So 1 over 1/2, okay, is equal to 2, okay? Let's do one problem here, and then I'll let you do the rest. Let's do uh, letter C. Okay, so letter C. I'm going to do letter C here. I'm going to copy it down. I have 2/3 over 7. Now, if you notice, I am emphasizing my main fraction bar so that I know how to write it as a division problem. So 2/3 divided by 7, or 2/3 over 7, is the same thing as 2/3 divided by 7. Okay? And from what we know about dividing fractions, we bring down 2/3, we change the division sign into multiplication, and we get the reciprocal of 7. Okay? The reciprocal of 7, which is 1 over 7. Okay? And I multiply straight. 2 times 1 over 3 times 7. I don't see anything that can be cross-canceled, so this becomes 2 over 21. Okay? So 2/3 over 7 is the same as 2 over 21 in simplest form. Okay? Now please do A, B, and D on your own. Okay, find unit rates. So when a fraction of a complex fraction represent different units, you can find the unit rate. Remember what unit rate is from the last lesson. We know that the unit rate is when the denominator is equal to 1. Okay? So 1 unit is the denominator. So that's what a unit rate is. So let's take a look at this example and let's see how this works. Josiah can jog 1 1/3 miles in 1/4 hour. Find his average speed in miles per hour. Remember, we had this problem also in the last lesson, and we know that, okay, to be able to find the average speed, we need to divide the distance by the time, okay? So if we're going to be doing that, okay, then we first write a rate that compares the number of miles to hours, okay? And from what we learned, that would be 1/4 or 1 1/3 miles over 1/4 hour, okay, to be able to find the average speed. So again, like what I told you, we are dividing the distance by the time, and that's exactly what we're doing here. Distance divided by the time. So if we get our main fraction bar, convert it into a division right here, this becomes 1 1/3 divided by 1/4. Now, if you notice when you're dividing mixed, okay, mixed numbers, okay, you need to convert 1 1/3 into an improper fraction, which is 4/3. So 1 1/3 is converted into 4/3, and we simply bring down 1/4. Okay. After we converted it into a mixed number, we can now, okay, uh, use the rules of division of fractions by getting the reciprocal of 1/4. So we get the reciprocal of 1/4, okay, which is 4/1. We change division into multiplication, and then we multiply 4/3 times 4/1. And by doing that, okay, we get 16/3, okay, because we multiply 4 times 4, which is 16, 3 times 1, which is 3, gives us 16/3, and convert that into a mixed number, which is 5 1/3. So Josiah jogs at an average speed of 5 1/3 miles per hour. Now, if you notice, it's a unit rate, okay? Because when you say miles per hour, this is an indication that it's unit rate. Basically, what it's saying is Josiah jogs at an average speed of 1 1/3 miles per 1 hour, okay? That's why it's a unit rate because of that. It's saying it's 5 1/3 miles per 1 hour, or simply that. Okay, that's what makes it a unit rate. Let's take a look at example number 4. Tia is painting her house. She paints 34 1/2 square feet in 3/4 of an hour. At this rate, how many square feet can she paint each hour? So you know it's asking a unit rate because uh, it's saying each hour, which means 1 hour. That tells you that the denominator should be equal to 1. So again, she's painting her house, and she can paint at 34 1/4 square feet in 3/4 of an hour. Okay, so how many square feet can she paint in each hour? So let's take a look at this problem. Okay, we first write a ratio that compares the number of square feet to hours. So that means we are getting this number, okay, and 3 1/2, 34 1/2 over 3/4. That will be our ratio right here. There you go. Okay, that's our ratio. 34 1/2 square feet over 3/4 of an hour. We convert our main fraction bar into the division sign. So this becomes 34 1/2 divided by 3/4. Again, we get our 34 1/2, and then we need to make it into a mixed number, improper fraction. So this mixed number becomes an improper fraction, which is 69/2 divided by 3/4. Okay, now that's an improper fraction, we simply have to multiply. Get the reciprocal of 3/4, which is 4/3, change division into multiplication. Okay, we can cross cancel. Okay, from there we can cross cancel. Okay, so this is actually a 1 and this is a 2. LCD of 69 and 3 is 3, so 3 divided by 3 is 1. And 69 divided by 3 is, let's find out, 69 divided by 3. You have 2 here. 6 minus 6, 0, 9, 23. So this is 23. Okay? Or you can multiply straight as what the book did, which is 276 over 46. Okay? And if we do our math here, 23 times 2 is 46 over 1, or simply 46. Okay? So in this case, Tia can paint 46 square feet in 1 hour, or 46 square feet per hour. Again, this is an indication of a unit rate, feet per hour. Okay? Do these problems to find out. See if you understand, okay, the two examples. Do exactly as what we did for example 3 and example 4. Make sure you go back to those examples, and I'll let you do E and F. Okay? Final one will be a word problem, of course. On Javier's soccer team, about 33 and 1/3 of the players have scored a goal. Okay? Write 33 and 1/3% as a fraction in simplest form. So again, says here 33 and 1/3% of the players have scored a goal. Write it as a fraction in simplest form. First, we need to understand what percent is. So when you talk about the sign percent, okay, the sign percent simply means that you have a fraction over 100. That's what it's saying. Okay. So here, when you have 33 and 1/3%, it simply means that you have 33 and 1/3 over 100. Again, that's a definition of what a percent is. From there, okay, we get our main fraction bar again. We make it into division. So 33 and 1/3 divided by 100. We convert 33 and 1/3 into an improper fraction, which is going to be 100 over 3 divided by 100. Okay, let me bring this down right there. Okay, and then we use the rules for division of fractions. Basically, we get the reciprocal of 100, which is 1 over 100. And if you notice, the 100 cancels out right there. Okay, and the answer now is left to 1/3. If I multiply 1 times 1, that gives me 1. 3 times 1 will give me 3. So about 1/3 of Javier's team has scored a goal. Okay? So rewind this if you still didn't get it, and then let's see if you can answer the following problem. Okay? And that's it. Thank you for watching.